Okay, welcome back. This is the fourth video in our series on fusion turning. Today we're going to talk about how to do face turning, roughing, and finish turning. Stick around, it's going to be whimsical. In the previous video, we covered how to do the setup for this project, FML1. Today, we're going to talk about how to actually do the operations necessary. So most often, the part is going to be a saw cut part. So this surface here is going to be rough. And we're going to need to do a facing cut in order to clean it up. Furthermore, from 2 videos ago when we talked about how to build the chuck with the part in it, we set the part in 20 thousandths so that we leave room to make sure we can make that nice facing cut to ensure we get a finished machine surface on the very end of our part. So to do that, we're going to first go to facing. And in facing, we have 5 tabs that we need to address. The first tab is mainly dealing with the tool. So we're going to go ahead and hit select tool. And in a previous video, I also covered how to load the tool library. So I have right here TL1 FML. So I'm going to go ahead and click on it. And there are 3 tools currently in the library. And we have a general facing turning tool for non-ferrous metals. Aluminum is a non-ferrous metal. And from our previous videos, we know we're cutting on aluminum 6061. So we're going to go ahead and select this. Furthermore, the default is to aluminum 6061. But if we were cutting on brass, HDPE or acrylic, we could go ahead and switch the feeds and speeds right here. Because when we hit select, you'll notice that it inputs our feeds and speeds. And these are speeds that work for my machines under the parameters I teach. They're not necessarily the most efficient because I'm in an educational environment. I don't really care that much about speed. I care more about not breaking things. So if you're outside of the educational world, then these numbers may not work for you. So it automatically populated this. If we had forgotten to adjust it, we could adjust it here to whichever material we want. We're going to go ahead and stay with custom. We can also manually override aluminum's numbers here. For tool setting, we are at a 0 degree. For our shop, we can basically twist this tool if it wasn't actually facing directly 90 degrees to the axis of the part. So our next tab really doesn't need to be adjusted. It basically is saying the model front is the front. Is there an offset? And you can see here that the model front is in there. It's negative 20 thousandths, so there's no adjustments necessary if we built the part correctly in the assembly. Okay, radius, these have to do with clearances, how close or how far the tool has to be or needs to be from the part. And obviously if you hover on any of these, it gives you that window that'll kind of explain what it is. For this very first part, it's very straightforward. And we're also not going to make any adjustments here. But basically the clearance is how far the machine will wrap it in before it slows down. When it pulls out after it makes a cut, that's the retraction height. The outer diameter is the maximum diameter we're going to cut, and the inner diameter is the minimum diameter we're going to cut. These two become very useful if there's a feature you don't want to address that's at the very center until later. We would use that, but in this example, we don't need any of these. On the passes tab, cycle direction means do we want to cut from the inside out or from the outside in, and in our case, we are cutting from the outside in, which means we're going to start on the outside and move towards the center. The tolerance is 4/10, which is perfectly fine. That has to do with trying to stay on the exact surface. Reduce feed rate, compensation type, we're going to do in computer. There will be examples where we talk about where later. Multiple passes we're not going to use. And then stock to leave. If we were to do a cleanup pass later, we could actually tell it to stay away from the surface. For this facing pass, given we're only cutting 20 thousandths off, we're not going to make any adjustments here. And then last is linking parameters, and this has to do, you can do full retract, partial retract. We're going to leave these alone. You can set the Z safety, how close we are. to it. We're not going to change any of these. Same with X. And then lead in, lead out has to do with where the cutter comes in and how far that is. Once again, we're doing a very safe maneuver. We're not going to adjust any of these today. So we're going to go ahead and click OK. And you're going to see here that it draws in. I'll look at it from above. That it's drawing in. The cutter's going to come, approach. It's going to angle in, and then it's going to face down. And if we zoom in here, you're going to see it's going to pull out at a 45-degree angle and then retract back to the starting point. And that will produce our facing cut. Facing is quite simple. It's very easy to do. So we now have our first of 3 operations needed to make this part. Okay, next we need to remove a bulk of the material here. There's all this material in here, and we're going to use roughing, which as you see in the icon, produces a series of lines that cut it away. I have this example here to talk more about what roughing is. So roughing is a series of, it's going to go in, it's going to make a cut, it's going to retract, it's going to come back, and it's going to do all of that. And the 2 things we need to understand in roughing is, 1, what is the step down for each pass? And second, how much material are we going to leave on all faces, on both the X and the Z face, so that we can have a finish pass, so we get a nice, beautiful finish at the end. So those are the 2 major factors when dealing with roughing. And in manufacturing, time is money. So the bigger the step down, the less we have to cut off on the finish pass, the ideal. Once again, we're in an education environment, so we're doing quite conservative cuts. Back into Fusion, we have roughing. We're going to click here. Now it automatically defaults to the last tool we used. And for us, that is the exact same tool. This is a 1-tool project. It's the tool, which it already has listed right here. We are cutting this on our TL1, which we have no coolant. So we're just going to click disabled for now. And then we are not using the tailstock, so we're going to leave that unchecked. We're once again cutting from the outside in. The tool orientation is not changed, so we're leaving that blank. We are using the aluminum 6061 settings. And then the insert and holder, none of this needs to be addressed down here. So we're going to skip all of this for this part. Our next tab has to do with geometry. So we're starting at the front of the model. We're going to the back of the model. And the big thing here is we want to offset it just a little bit beyond what we need for this. In a normal situation, we would want to offset it the thickness of the parting tool. So when we part in here with our parting tool to cut this off, we would have a clean surface to work from. Our parting tool is an 1/8 of an inch parting tool, so we're going to offset this negative 0.025, and that's going to leave us, it's going to continue this diameter to that point. We have no grooves to cut, as you see in the image. We're going to do what's on the right there, where it just goes over them, but we don't have any. Then rest machining, we don't need to address, because that has to do with parts that we couldn't get with this tool coming back on another tool. We'll talk about that later. So going to geometry, once again, this is the same as the first one. It's talking about the clearance, the outer radius, and the inner radius, and essentially it's saying we have it on the OD of the stock is our outer radius, and the stock ID is our inner radius, which doesn't really have one because it's solid. But we don't, the short version is we don't need to make any adjustments to this. Once again, cycle direction, we're moving horizontal, we're moving from front to back, and we're allowing grooving. There's no groove, so we don't need to worry about that. Machine multiple regions, we're only doing 1. We could check use can cycle. This has to do with how the code is written. We're going to actually not do can cycled for this example. And then passes, so our tolerance is still 4/10. The maximum depth of cut they have set to 30 thousandths, and this is this step down right here. So they are taking off 30 thousandths per pass. We lower this to 15 thousandths, about half of what they have. So we put in 15 thousandths here. These things we're talking about here, even cuts, that'll make the step downs even, making sure they're smaller than 15 thousandths. we are not going to do that. We're going to have a shallow cut either at the beginning or the end or both. We do want to make sharp corners. We're skip wall passes we're not doing. No dragging we're not doing. No machine undercut we're not doing. These will all be covered later. But what does matter is down here in stock to leave. So right now we have 4 thousandths for basically the diameters and for the wall faces. We're going to up that number just a little bit just to give a cleaner finish pass. So going here, we're going to up this to 6 thousandths. We're going to use this preserve feed rate. Rapid to the next cut, we do want that, so it's going to switch to rapid movements. Safe approach in Z in both directions. Clearance approach in X in both directions. And then the clearance is we are adding 7.5 thou in both directions. This is how much, this has to do with how much it's retracting up before it comes back. And these numbers are all fine. And then angled entry is fine, and then retract, all of this is fine. So we make no adjustments. We're going to go ahead and click OK. And it should show us our passes. And you can see this is going to take a lot of passes to get down there. And if we wanted to increase this, because this is going to take too long, we would right click and edit, and we would actually go back to here, and we are going to actually increase this from 15 to 20. This was more of a lesson on how to make an edit if you get something you don't want. So we go ahead and click OK, and you'll notice that now less passes are coming. So that concludes roughing. So we're going to go ahead and do a quick simulation. So if we hit simulate, we can go ahead and hit play, and it's going to do the facing, and then it's going to do each roughing pass. I'm going to speed it up a little bit so we don't bore each other, and there they all are. But if you notice, this is still big by that 66 thousandths on all surfaces. So we're going to exit this, and we have to do a finish pass, which will cut us right to the diameter we need. So go ahead and click on that. Remember, it'll default to this. We're still working outside in. Tool orientation hasn't changed. We're switching to aluminum. And then the insert holder hasn't changed. Nothing to adjust here. Once again, the front and the back are our thing. We do need to offset that negative 25 thousandths so that we get that area for when we part this off, which we're not doing in this example. No grooves, no rest machining. These stock diameters we did not adjust. And then direction is from front to back. We're skipping grooving. Doesn't really matter. Tolerance is fine. We're doing our compensation in the computer. Maximum step over is 1. This is our maximum step over, but this doesn't really apply because we're only doing one pass. We are allowing sharp corners. This is a very rigid part. If you're working on a very long, thin part, it can actually bend under the pressure. So you would do what's called a spring pass, where we cut it twice to make sure we get right to the right size. No dragging shouldn't apply because we're coming only getting bigger in the x-axis. And then machine undercut doesn't apply. And then we want the finished pass, so we do not want stock to leave. Linking parameters, all of this is the same, so we don't need to adjust any of this. And we go ahead and click OK. And you can see it's hard to see because it's following exactly the path, but it is going to make a finish pass. One thing to note is because there's a radius on the tip of our cutter, there will actually be a small fillet right here. In some cases where this has to be 90, you're going to have to do another operation, which I'll teach later in the lessons. But for this example, we are kind of ignoring that little problem. Before we get to another simulation, we notice we have a problem. Remember, a orange triangle is basically warning you that Fusion made an edit that you didn't address. And if we read here, it says the lead out has been modified due to gouging with the remaining stock. So if we edit this, it has to do with the lead in, lead out being different. So to go in and fix this, we're going to go into the lead out where it said the problem was, and we have it same as lead in. So we're going to actually turn this off. And we can actually also just turn off lead out. We don't want this little curve. And if we click OK, you will see that the new one has a green check because it's going to pull straight out and then come out. Let's go ahead and watch a simulation. We need to make sure we check the box on the setup so it'll do all three. We're going to go ahead and hit simulate. I'm going to slow it down just a bit. And we're going to hit play, and we're going to see it's going to go facing. It's going to do all our roughing passes. And then it should go back and do a final finish pass on the part to get us to our final dimension. And there's our finish pass. And now we have our part machined, leaving some gap on the back. We're going to exit the simulation. All our programs have been run. The last thing we need to do is we need to generate code so that we can actually go run this on a machine, or in our case, in the classroom, you're just going to run this through the Haas simulator to prove that it works. So the next step is we're going to go to G1, and we need to select a post. Now, I already have a post listed here for Haas turning, but I'm going to show you how to get yours. You're going to go to post, you're going to go to Fusion Library. You're then going to go over here to turning, and we're going to switch to just Haas because Haas is the most common. And we're looking for the generic Haas turning, which I believe is at the bottom. And then you would hit select so I don't get another copy of this post. But I'm going to go ahead and hit cancel. You would hit select. Mine would be listed right here. And now we need to talk through a few things. It does input our program number and our name. In the output folder, I recommend you change this to the downloads so that you know where it goes. And then it will input these things here. We can also save a new name here if we wish. There are a few configurations we need to set up specifically for this machine. Number one is we do not have chip conveyor. The maximum speed of the TL1 is 2000. So you would need to do that. Under preferences, we want to make sure these are checked. Option stop, use can cycles, use simple threading cycles, and use tool changer. The big one, the most important one, because we have a tailstock and a tool changer, we have to modify our home position. And our home position where we can do a safe tool change is -3 and -10. You must put those in for projects that we actually run on that machine, or the tool changer will collide with the tailstock. And then lastly, we want to make sure we do both Z, then X. So we're going to pull back in Z, and then we're going to move in X whenever we do a tool change. The rest of this is all the defaults, so you don't need to do it. You can go ahead and when get this all done and hit post. And you're going to notice we get an error here at the bottom. And if we click on that error number, and if we click on view error report, we're going to get this window popping up. And if we read this, it basically says, here's our error. This is not an uncommon thing for you to get, so I want you to be able to decipher it. It says that the program number is out of range. And one problem, for whatever reason, the Haas post for the turning only wants a 4-digit number, not a 5-digit number, but all the rest of our Haas machines want 5. So we're just going to remove a 0 in the middle. Wrong 0. There we go. And we are, I guess it didn't matter. We're just going to remove a 0 here. So it's 2101. And we can go ahead and hit post. And do I want to override it? Yes, because I had the mistake. And if we click on this window here now, view the NC, it's going to load our code that we can then check. So then we can go through, notice it has our name in it, has our facing, has our roughing, which is our longest part because we have all those down, cut, return, down, cut, returns. And then we have our finish profiling and our return to our home position. So next step would be to load this onto our flash drive and then take that to the simulator and show how to simulate it. That will be the next video in our series. Thank you for watching. I hope you learned something, and I'll catch you in the next one.